All right, hello folks, and welcome to one of your assignments. This one is going to be our activity 1, test out your equipment. So, in this activity, what we're going to be doing is we're going to be taking our breadboard right here, and we are going to be placing our 3 basic AOI chips onto it and testing the gates. Honestly, we're doing this just as part of me making sure we know how to use our breadboards, because once I know that we all know how to use our breadboards, going forward it should be a lot quicker and easier. Also, I want you to start getting a little experience with how these chips are wired internally. One thing I've been learning from our classes together is working on this stuff synchronously in class is really freaking hard. So I'm going to start trying to release videos for you prior to class where I'm going to go through wiring each thing. So for this assignment, the assignment says, hey, you can skip the switches if you want to, but I know switches are something we're still struggling with. So what I want to do is I have wired up one of my switches the way we need to already, and I am going to go in and I'm going to add a second switch. That way, when I'm testing some of our gates that require multiple inputs like these two, I can use a switch for each of the inputs, and then I can go through and test the gates. First thing, I'm going to place it into my breadboard like so, and just follow along. The placement of these wires is really important. The length doesn't matter, but where they start and end is what matters most. So I'm working this. I'm going to go and I'm going to grab myself an orange wire. It's just a short one. And I'm only grabbing a short one just to keep my breadboard tidy. And I'm going to go and I'm going to take it and I'm going to put it into my breadboard so that I make a connection from power to the furthest left part of my switch there. Then I'm going to go in. I'm just going to use a gray wire this time. And if your wires are really bent up like this one is and falling apart, I usually ditch them. If you run out of wires, I can hook you up with a spool of wire to cut your own wires later in the year. Or I can get you another kit. They are considered expendable. Now, on this other switch, I'm just going to do the same thing. Except now I've got a wire from ground over to that row for the switch. You notice in both cases with these switches, I've left the middle pin of the switch open. There's nothing connected to it yet. That's because these switches are going to be how we control everything else in this circuit. And so I can then later come in and put wires into those middle pins and use those to control our different logic gates. Next thing I'm going to do is I'm going to take our 74LS04 right here. Ooh, there we go. Now you can read that. You take my 74LS04 right there. Wow, you can really see the refresh rate of my lights in this video. And I'm going to go place it into my circuit. I'm going to put it somewhere where I'm away from these rails because I need to be able to connect directly to the rail, and it's a lot easier if I avoid these jumper wires that I've put in here. Right? You're welcome to spread out your breadboards while you work on these things. So now that I've done that, I've got my 74LS04, and if you look at the assignment on the data, there's going to be a picture on there that looks kind of like this. These are taken out of what's called a data sheet. It tells us a ton about what happens inside the chip. For instance, on this chip, which you'll notice has all these pins on it on the sides, right? These chips have a little divot in them. I'll show you on our 74LS08 right here. I need a macro lens. You can kind of see the divot right there on this side of it. That divot tells us that's where the left side is in our images down below. So what we're going to be doing is we are going to come in here and we need to connect our chips to power and ground in order to have them work. Now, the reason being is that basically our gates are able to channel power or ground to their outputs. They'll connect the power and ground to the output depending on the conditions of the inputs, but the inputs to the gates do not supply power or ground to the output. That power or ground comes from hooking it up to VCC on the upper left, that is our power section, and then to ground on the lower right of the chip, that is our grounding section. We will do this for every chip we use all year. You're going to make sure that you double check these data sheets, because on here, power and ground, VCC and ground, VCC is another way to say power, these are always in the same place on these chips. But in some of the extra chips we use later in the year, that's not going to be the case. So I've hooked up power and ground to my 74LS04 right there. This is an inverter chip. Now, the way I'm going to test that is I am going to take an LED, connect it to the output. And with this LED, I'm going to take the longer lead, and I'm going to put it into the pin that connects to the output of this logic gate. So, on here I can see it's not the first pin is the input, the second pin is the output. So I will put the long pin of the LED into the output, and the short pin of the LED into ground. The next thing I'm going to do is I'm going to take a wire and run it from my switch over to the input to that logic gate. Sorry about the shaking, that's my weird phone stand. And I will pause in just a moment to take care of that poor buddy crying over there. But we've connected a wire from the middle pin on the switch over to the far left pin on our logic gate. And then I'm going to turn on my circuit. You want to make sure you always wait to turn on your circuit until after everything's connected. Now it's hooked up. I've got power running into the switch through to that input. You'll notice my LED is off. If I move that switch over to ground, my LED turns on. Now, these blue LEDs are very dim when you're running them off of 3.3 volts. You are welcome to move them to 5 volts to get a little bit more intensity in your LED. Now, these chips will handle 5 volts just fine, but you always want to check to make sure you know. You're supposed to run them at 3.3 volts for logic levels, but they are very tolerant and good chips to learn on. Alright, I'm going to pause right there, and I'm going to go take care of my baby, and I'm going to come back and we're going to do the rest of these. Okay, now we're back at it. So the first chip we tested was our 74LS04. That is our inverter chip. When we put the switch to power, power runs through, from power, through the switch, through the yellow wire, into the input to the 74LS04. Then, because this is an inverter, it connects the output to ground, because that is what inverters do. If you're interested, we can spend some time at some point talking about what is happening deep inside this chip to make that work. But right for now, we just need to make sure we understand what the chip does. The chip, when it gets power on the input, connects the output to ground. When it gets ground on the input, it connects the output to power, thereby lighting the LED in this case. Or as we move further in, we'll control more and more things with these chips. So I'm going to turn off the power to my circuit. I am going to disconnect my wire here, disconnect my LED, and then since I've tested the 74LS04, let's draw a truth table for that before I move on. In the 74LS04, we have an input A and an output, we'll call the output O. When our input A is a 1, the output's a 0, and when the input's a 0, the output's a 1. Right? Now we're going to do that again, but we're going to do that for our other chips, and our other chips have more inputs. So we're going to make a new truth table here, and we're going to leave ourselves a spot for some output. Now, whenever we test something, we need to test all of the inputs for it to be a truth table. So that means for this 74LS08, since we have 2 inputs to the 1 output, we are going to need to test 4 different conditions. 2 inputs, 4 conditions. We have to test the condition 0, 0. Then we have to test the condition 0, 1. Then the condition 1, 0. And the condition 1, 1. For those of you who are familiar with binary, you'll notice we're counting 0, 1, 2, and 3. If you're not familiar with binary, don't be stressed. We are going to learn more about binary as the year progresses. So right here, we'll do this for the 74LS08. That's an AND gate. So I'm going to take that AND gate, I'm going to put it into my circuit, and since it has power and ground in the same places as the 74LS04, I can conveniently just plug it right back into the same spot, leave all my wires in place. You'll notice, however, I did unplug the LED and the wire, because those are going to be in different places now. On the 74LS08, if I'm looking, I have input, input, output. That means the third pin over is going to be my output. So I'll go to the, not the first, not the second, I'll go to the third pin over. I'll stick the long lead of my LED into that row, and the short lead of my LED, or the short wire off the LED, into ground, just like so. Then what I'm going to do, I'll come in, I'm going to hook the middle pin of my switch up to the first of the two inputs to that gate. Then I'm going to grab another yellow wire. I'm just using yellow wires because they're long, and that makes my life easy. I'm not really concerned with wiring this circuit super cleanly, since I'm just going to keep testing gates. In a bigger circuit, we would want to make sure all of the wires are precisely the same, or are all the exact correct length, so they don't bulge out like that. However, for this kind of stuff, it's okay. This is called rat's nesting, and this is an example of good wiring. This is lazy wiring that's going to make it hard to troubleshoot things. So now I have one switch going into the first pin, one switch going into the second pin, and now I can go in and I can turn on my power, and I'll be like, oh hey look, I've got both of them connected to ground. So both my switches are on the ground side. See, we've got ground coming to the switch there. The switch is on the side of ground. That correlates to 0, 0. My LED is still off, so 0, 0, it's a 0. I'm actually going to switch my power over to 5 volts here to make it more visible for all of you when we do this assignment. You should never change your jumpers while your circuit's powered, but it's not my first rodeo, right? I've done this before. So now I've tested my 0, 0 condition. Both switches are at 0. My output was a 0. So now I'm going to switch my B switch, one of my switches, to a 1. My A switch is 0, my B switch is 1. So the B switch is connected to power, right? Power goes right there into the switch, all the way down to the input. Ground into the switch, all the way down to the input. And we'll see it's still a 0 here. Then, please note, we're not testing both of them on. We're now going to test the A switch is on, the B switch is off. And that also gave us a 0. Lastly, we're going to test both switches on. The LED lights up. That's going to give us a 1. There we go. Sorry if that's a little hard to see. I am using a bunch of clamps to make this data table visible here. And hold my phone. There we go. So, you'll see that for this one, an AND gate, we had to have one input at a 1 and the other input at a 1 in order to get an output of a 1. It's an AND gate. The inputs all need to be on, or 1, in order to get a 1 at the output. Alright, AND gates are done. I'm going to turn off my circuit. And now one handy dandy thing is the 74LS32 has the same input and output pattern as the 74LS08. It also has power and ground in the same spots. So I can take my take my 74LS32 chip, see that divot on one side of it, that tells me that's the left, and I am going to plug it in right where my other chip was. I'm going to set both my switches to 0 because that's my first condition that I need to test in a 74LS32. You'll notice my input pattern didn't change. This is still all the inputs possible for a 2-input gate. Switches are at 0. My setup, everything's wired up right. I'm going to turn on the power. So right now, with both switches on the right side, they're at ground. That's going to be a 0 for my output. All right, I can test my next one. That's B is a 1. Oh, hey, look, I turned one on, and the light turned on. But my next one to test is A is on, B is off, so I will turn B back off, turn A on. No, hey, look, that's on. Now, one thing I want to point out that a lot of people miss with OR gates is that they think that when I turn both of the inputs on, it's going to turn off. Let's see what happens. Both inputs are on. It's on. Because is one of the inputs a 1 or is the other input a 1? Well, if this input's a 1 or the other input's a 1, it's an output of a 1. No matter what, if any of the inputs to an OR gate is a 1, our output is a 1. All right, well, I hope this helped you a little bit, showing you how we are going to wire up this assignment to test out our circuit. If you're stuck today, I'm going to have you come and watch this. All right, hope you have a good rest of the day.